RHS Pre-Calculus presents.
Discovering trig identities.
Our goal today is deriving and applying the cosine of a sum formula.
Just a quick reminder, the distance formula will be applied and utilized along with the unit circle in order to derive the sum of a cosine.
In this unit circle, distance 1 equals distance 2 because angle A plus B equals angle A plus negative B. This means that the two distance formulas for the triangles will be the same. Point C is at cosine A plus B sine A plus B because in a unit circle, the points are determined through the sine and cosine functions of the corresponding angle. The x-coordinate is to the cosine of the angle and the y-coordinate is to the sine of the angle. Therefore, the other points are labeled as such. Point D is at cosine A sine A and point F is at cosine negative B sine negative B.
To solve the first distance formula, you need to substitute the value x2 with cosine A plus B and y2 with sine A plus B. To solve the second formula, x2 should be replaced with cosine A and x1 with cosine B. For the y-axis points, y2 is replaced with sine A and the point y1 is replaced by sine B.
To begin, simplify the two formulas, then square both sides of the equation, then multiply all the values in parentheses out.
We can now use some trig identities we already know in order to further simplify the two formulas. Cosine squared plus sine squared is equal to 1. Based on this fact, we can further simplify the formulas, replacing the circled values with 1, giving us 1 minus 2 times cosine A plus B plus 1 equals 1 plus 1 minus 2 times cosine A cosine B plus 2 times sine A sine B. Then subtract 2 from both sides and divide by a negative 2.
Following these final steps, you will have the simplified final product and have successfully derived the cosine of a sum formula. To apply the formula, let us do a sample problem. Find the exact value of cosine 105 degrees. To find the decimal answer, we could just plug it in a calculator and receive the answer of 0.259. However, the question asks us to find the exact value.
To do this, we must apply the cosine formula. 105 degrees can be formed through adding 45 and 60. This gives us the cosine of 45 plus 60. Applying the formula, we get cosine of 45 times cosine of 60 minus sine of 45 times sine of 60.
Solving, we get square root of 2 over 2 times 1/2 minus square root of 2 over 2 times square root of 3 over 2. Simplifying this, we get square root of 2 over 4 minus square root of 6 over 4, which, when you put it in a calculator, gives you the same answer of 0.26.
Tune in next time, where we will derive and apply the sine of a sum formula, or sine of A plus B.